Welcome to my YouTube channel, A Binary of Civil. So in this lecture, I am going to solve the assignment number 6 of fluid mechanics. So in the first question, a streamline is defined in terms of a stream function psi and potential function pi is defined as, he has given pi is equal to constant, psi is equal to constant, some options. So what is the meaning of a streamline? So streamline can be defined as a line. Streamline can be defined as a line along which the stream function is constant. So that is psi is equal to constant. So along any line, if the value of psi, that is a stream function value constant, we call it is a streamline. So option D for question number 1. Coming to second question, a flow has parallel curved streamlines. That is, this is first one, this is second one, this is third one. These are curved and parallel streamline. So here direction changes as these streamlines are curved. The direction of flow changes. So as the direction of flow changes, they will exhibit, the flow will exhibit normal acceleration. Okay, and the space between these streamlines is constant. He has given it is a study. Study means all the parameters of flow with respect to time are constant. That is, these flow will not exhibit any temporal or local acceleration. It will exhibit only convective acceleration. So here normal acceleration, convective acceleration. So normal convective acceleration will be possessed by the streamlines which are given in this problem. So option D for question number 2. Coming to next question, a flow is said to be rotational when obviously every particle or every fluid element can rotate about their center of mass. Then the flow is said to be rotational flow. So that is, every fluid element has finite angular velocity about its mass center. When the element of fluid having finite angular velocity about its mass center, it can able to rotate about its mass center. Then the type of flow we call it is rotational flow. So option C for question number 3. Coming to question number 4, vorticity is given by. So there is a definition, vorticity is 2 times angular rotation. Okay, so this can be indicated by this symbol. This symbol in Greek letters called Z. Okay, so that is equal to 2 times angular. This is angular rotation. So by the definition itself, vorticity is 2 times angular rotation. Option A for question number 4. Coming to question number 5, velocity potential exists for, it will exist only for irrotational flow. Whatever be the type of fluid, it will, if it is a irrotational flow, obviously then there is a chance of development of velocity potential flow. All irrotational flows can exhibit velocity potential function. Coming to next question, 6th question, lines of constant phi. Obviously, we have a concept that is flow net. In the flow net, these are all the streamlines. That is, streamline symbol is psi 1, psi 2, psi 3, psi 4. These are all the streamline, and These are velocity potential lines. This is pi 2, pi 1, pi 0, something like. And the angle of intersection between pi lines and psi lines is 90 degrees. So that is or normal to streamlines. They will intersect at 90 degrees perpendicularly. Okay, option C for question number 6. Coming to question number 7, he has given pi is equal to 3xy and calculate components of velocity at point 1, 3. So that is u is equal to, we know velocity component along x direction is the first derivative of pi line with respect to x. So that will be minus 3y, it will become minus 9. And v is equal to minus dou pi by dou y, that is equal to minus 3x minus 3. When you substitute the point, so you will get minus 9 minus 3. So option A for question number 7. And coming to indicate the incorrect statement about a flow net. So the basic thing is flow net is a combination of pi lines and psi lines intersecting normal to each other. So now it is applicable to irrotational fluid flow. Obviously flow net is applicable only for irrotational flow because the stream function will exist only for irrotational flow. When the stream function exists only for irrotational flow, flow net is combination of stream function and velocity potential function. So flow net will also exist only for irrotational flow. So statement 1 is correct. Coming to second statement, for a given boundary is the same whether the flow is one direction or other. Obviously the boundary conditions will depends upon the flow net. It is not depends upon the direction of the flow, whether the direction of the flow is 1D flow or 2D flow or 3D flow. Flow net will be same. Okay, so option B also correct. Coming to option 3, for a given boundary is applicable to one chosen direction of flow. The flow is reversed. Flow net will change. Obviously flow net will never change. Even if we change the flow from upstream to downstream or downstream to upstream, that is because of reversal of the flow net will never changes. So option C is incorrect. Coming to option 4, will be no constructed that size of the mesh is inversely proportional to local velocity. Obviously when the size is a parameter of velocity. So this is a correct statement. Option C is the answer. So that is answer C is incorrect statement. Coming to question number 9. Envisaged incompressible flow about a stationary cylinder in uniform flow can be simulated by a superposition of uniform flow and a doublet. Is a basic statement. So answer B for question number 9. Coming to question number 10. Which of the following stream function is possible irrotational flow field? Obviously for irrotational possible flow field there is a function called or equation called Laplace equation. So the Laplace equation is del square psi is equal to 0, that is dou square psi divided by dou x square plus dou square psi divided by dou y square is equal to 0. So let's go with first option, psi is equal to y square minus x square. So first we will calculate del square psi divided by dou x square, that is equal to minus 2, and del square psi divided by dou y square is equal to plus 2. So minus 2 plus 2 summation will be 0. So when the Laplace equation satisfied, this indicates a possibility of irrotational flow field for the given stream function. So option A for question number 10. And the tangential component of velocity in a two-dimensional flow of incompressible fluid. So that is V suffix theta is equal to minus C sine theta divided by R square. So magnitude of resultant velocity will become C divided by R square. So option A for question number 11. Now coming to last question, he asked us to calculate circulation around a closed curve. So the x values are changing from x to 4 to 8. y values are changing from 2 to 8. He has given the function u is equal to 16y minus 8x and v is equal to 8y minus 7x. Clear? Now circulation definition, according to circulation definition, circulation is equal to line integral over velocity and space. So that is equal to this line integral over u dx plus v dy. So what is the value of u? 16y minus 8x dx plus v is 8y minus 7x into dy. So this line integral. Here the x limits are 16y minus 8x. The limits of x are, y limits are y is equal to 2 to 8. The limits of y x are x is equal to 4 to 8. So that is 8y minus 7x. So if you will analyze this, you will get the value as 288. Okay. So 288 units of circulation by the given equation. Okay. So the answer for question number, that is last question, is 288 units. Okay. Thank you.